Hello Nabonds. So today let us see NOT gate. So first, as usual, logic symbol. Logic symbol ಯಾವ ಥರ ಇರುತ್ತೆ ಅಂದರೆ NOT ಗೇಟ್ಗೆ it has one triangle with a bubble. Every logic gate has only one output. This is output represented by Y. And in NOT gate there is this one thing to remember, that it doesn't have many inputs. It has only one input. It has only one input, that is A. It has only one input, that is A. So note this thing about NOT gate. Symbol ಯಾವ ಥರ? Triangle with a bubble. Output is only one for every logic gate. But in NOT gate you have only one input. You have only one input. See, NOT gate is also called as inverter. It is also called as inverter. What is inverter? Before that, let me tell you an expression. Output Y is A bar or A complement. See, for AND it was A and B, that is A into B. For OR it was A or B, that is A plus B. And for NOT it is A complement. What is this A complement? Input ಏನೇ ಕೊಡ್ತೀವಲ್ಲ ಅದ್ರ ಉಲ್ಟಾ ಬರುತ್ತೆ. You will get to know in truth table. Truth table ಇಲ್ಲಿ ಯಾವ ಥರ ಬರುತ್ತೆ? ಇಲ್ಲಿ truth table ಯಾವ ಥರ ಬರುತ್ತೆ? I told you the formula. How many input combinations? How to find out? 2 to the power n. n ಅಂದರೆ number of input. So 2 to the power 1 will be 2. There are only 2 input combinations. So first input, then output, then this is Y. Output is Y, right? That is A complement. Input is only 1, that is A. There are only 2 possibilities. So divide this truth table. Input separately, output separately. After you divide, there are only 2 possibilities, 2 input combinations. A can either be 0 or it can either be 1. So 0 and 1. So what NOT gate actually does is, when input is 0, the output will be inverted, that is A complement. That is A complement means 0 will become 1 and 1 will turn to 0. 0 will turn into 1 and 1 will turn into 0. 0 will turn into 1 and 1 will turn into 0. 0 will turn into 1 and 1 will turn into 0. So when the output is high, the input will be 0, and when the output is 0, the input will be high. So NOT gate is also called as inverter. Remember one thing about NOT gate. This bubble in the NOT gate represents inversion. That is inversion. Inversion means ulta. Inversion. 0 becomes 1, 1 becomes 0. So now let us continue this thing with NAND gate. See, NAND is nothing but negated AND gate. Negated means see, AND symbol. What is the symbol of AND? It's like D. How many outputs? Only one output every logic gate has. So it was A into B, right? This was AND gate. This was AND gate. But NAND gate, what happens is negated. That is, in front of NAND gate, when you add NOT gate here, in this part, in this region, when you add NOT gate, it becomes NAND gate. So the logic symbol of NAND gate is like D. This NOT gate is not shown actually. So at the tip there is just a bubble which represents inversion, and rest everything is same. Y is equal to, here Y was, A was the input, Y was A complement. Here A and B is the input. Output will be A into B. But since we have inversion, what will be the output? A into B complement. That is A into B bar. See, when there was only one input here, that is A, output would be inverted of the input. So here what happens? A into B. See, AND is like A into B, right? Output. So here the output will be A into B. So when A into B passes through NOT gate, what will be the output here? Y is equal to A dot B complement, right? So that is NAND gate. Now how to write the truth table? See the truth table. Let me tell you. See, inputs. How many inputs? A and B. Output, there is only one, that is Y, and the output is, expression is A dot B complement, because there is a bubble which indicates inversion. Now divide this truth table. Inputs column is separate, output column is separate, and again in inputs column you have A and B, so divide it. So there are two inputs. How many combinations? 2 to the power 2, 4 combinations. You have this formula here. So 2 to the power 2, 4 combinations. That is 0, 0, 0, 1, 1, 0, 1, 1. Now you know that in AND gate you used to get 0, 0 is 0, 0, 1 is 0, 1, 0 is 0, 1, 1 is 0. I told you that it will be inverted, that is complement. See now 0 and 0, here the output is 0. But when it passes to the NOT gate, when 0 passes to the NOT gate, what will be the output? It will be 1. So 0 into 0 was 0 in AND gate, but 0 into 0 was 0, and here 0 complement would be 1. And similarly here now 0 into 1 is 0, it will be 1. Zero into 1 was 0. When 0 passes through NOT gate, output will be 1. And similarly 1 and 0 was 0. When it passes through the NOT gate, the output is 1. 1 and 1 was 1, but when 1 passes through the NOT gate, it will be 0. So this is NAND gate. So this is the logic symbol, truth table, and the working or equation of the NAND gate. See the equation, A into B complement. So now next let's see what is NOR gate. Yeah, NOR gate. So this is last gate which will be there for now. I'm just telling you what is required, okay? See, NOR gate, how it is this can be called negated OR gate. So what is the logic symbol? See, there is a OR gate, right? You have a negation, that means a bubble, inversion. So what is the output? There will be only one output. Output is Y. And how many inputs? 2 inputs, A and B. So this one we will compare to this circuit over here. See, this was normal OR gate, right? Now what I will do is, I'll add a NOT gate in front of it, and here I will take the output. So this circuit is converted into this symbol actually. NOR gate is this circuit, but when you combine these both, you get this symbol. So this is NOR gate. So let us see what will be the output expression here. See, output expression of OR gate was A plus B, right? Now when it passes through the NOT gate, what will be the output? A plus B complement. when you are passing A, output was A complement. When you are passing A plus B, output will be A plus B complement. So here you have inputs A and B, it will be inverted, but output ಏನು ಬರುತ್ತೆ A plus B complement. So now let us take a look at truth table. Let us look at truth table. So truth table is like there are inputs A and B. There is output, that is Y equal to A plus B complement. And now you divide this truth table. Inputs column separately, output column separately. Now in inputs there are again 2, so divided. So 2 to the power n is the formula to find out how many input combinations are possible. 1, 2, 3, 4, 5, 6, 7 or 8. So here n represents number of inputs. 2 to the power 2, how many combinations? 4 input combinations. So 0, 0, 0, 1, 1, 0, 1, 1. There are 4 input combinations. So 0 plus 0 was 0. 0 plus 0 was 0 in OR gate, but when it passes through the NOT gate, 0 will become 1. 0 plus 0 was 0, but when it passes to the NOT gate, it becomes 1. And now 0 plus 1 was 1. 0 plus 1 was 1, but when it passes through the NOT gate, it becomes 0. Because NOT gate inverts the input. 0. Similarly, 1 plus 0 was 1, but when it passes through the NOT gate, it will be 0. And 1 plus 1 was 1 in OR gate, but when it passes through the NOT, it will be 0. The inversion that is taking place, or the 1 becoming 0 and 0 becoming 1, is because of the bubble which is present in front of the OR gate. So this is all about basic gates being used, like AND, OR, NOT, and then now you have also seen NAND and NOR. These two are called as universal gates. Universal gates. Why they are called as universal gates is because using NAND, OR and NOT, you are constructing NAND or NOR. You can see here. You are constructing NOR by using these basic gates itself, and you are constructing NAND by using these basic gates itself, that is AND, OR or NOT, AND, OR or NOT. So these three are called basic gates, and these two, NAND and NOR, are called universal gates. So now I hope you are clear with logic symbols and truth tables. Remember these things, then we'll jump to digital trainer kit. Fine guys, then bye bye. Anabonds, let's see in the next video.